We are going live. And if y'all are feeling good, we can open the rooms.
I can admit everyone if
Yes, I messaged you on yes, I messaged you on Slack.
Okay.
We're good to open.
Admitting now.
Hello world.
All right. Hello. Can everyone hear me okay? Yeah, well, so nice to see so many people from all over the world. Indeed, we have folks from San Francisco, from Peru, Canada, the US, India, Canada, Argentina, Taiwan, Philippines, Australia, Florida, and the list goes on and on and on. So welcome to all. This is the third of CS50's New Year's seminar. This one focused on Linux, a popular operating system that actually underlies CS50's own IDE, or integrated development environment. If you've taken CS50 or some of our other classes using that platform, you'll know a little bit about it. But even if you have no idea what Linux is or how to use it, that's indeed the goal for today, to give you a taste of this operating system, a taste of that world, all toward an end of preparing you to use it all the more in something like CS50 or on your own Macs or PCs, ultimately as via some virtual machine. We're so pleased that we've had over 10,000 folks from around the world register for these and CS50's other seminars, an amazing team of 600 plus mentors who have wonderfully volunteered to answer questions either in the chat here today, in Zoom, as well as via Ed, the course's Q&A platform. So if at any point you find that you're falling behind, you missed something, you're having technical difficulties, not to worry. Everything will be available on the seminar's website, so you can access all of the slides and even the video recordings hereafter as well. Before I introduce today's teacher, we have a tradition of taking a group photo of sorts. If you would like to opt into this and turn your camera on, we'll give everyone just a moment. We will take a few seconds to take screenshots of as many people's cameras as we can. And then thanks to software written by one of our colleagues behind the scenes, Rong Xin, we will analyze all of the rectangles looking for faces and extract each of those rectangles and then compose them into one big mosaic that we'll post on the website as well. So here we go. If you'd like to put on your best smiles and wave to the camera, we will start flipping behind the scenes through the various screens of some 95 of us all here in the Zoom meeting at once. So this is using artificial
Thank
intelligence
you.
software, as it turns out, to figure out which of us is a face. And indeed, I think we now have enough for the software to do its thing. So welcome all. Allow me to introduce CS50's own Kareem Zadad, who works full-time with CS50 here in Cambridge, but was just a few years ago living and studying in Egypt. In fact, Kareem got wonderfully involved behind the scenes in CS50's Facebook group years ago, answering lots of people's questions. He caught our eye and we got to chatting some time ago. And then fast forward to today, where not only does he live in Cambridge and work with us here at Harvard, he also is the primary developer of CS50 IDE, the web-based programming environment that you'll use today and may very well have used in CS50 itself. And he helps develop and deploy so many more of CS50's tools. So without further ado, CS50's own Kareem.
Well, thank you so much, David. Hello, everyone, and good to see everyone here today. And welcome to a Taste of Linux. My name is Kareem, and in today's seminar, we are going to introduce Linux and the Linux command line. And we're going to scratch the surface of quite a few tools that would be useful if you decided to take CS50 in the future or even beyond that. If you haven't used Linux or the Linux command line before, don't worry. Certainly, if you have any questions about anything that we'll talk about during the seminar, feel free to ask your questions in the chat or on the Ed discussion forum at cs50.ly/seminars/ed, and we will try to answer as many questions as we can. Now, let me start by sharing my screen here on Zoom, and hopefully everyone can see my slides now. All right. So I thought we'd start by sharing a few quick links that hopefully should help you during the seminar if you'd like to follow along with us. And the first link is, if you'd like to access these slides, they live at cs50.ly/seminars/Linux. So if you'd like to follow along with that or access the links that are in the slides, this can be quite handy. If you do not have a GitHub account, please go ahead and create one at github.com/join. You will be using your GitHub account to sign into different CS50's tools. And the tool that we will be using today is going to be called CS50 IDE, which you can access at ide.cs50.io. So you can visit ide.cs50.io and log into CS50 IDE with your GitHub account. We are going to be demonstrating quite a few commands today. If you find yourself falling behind or you'd like to take a look at any of them at any point, feel free to visit cs50.ly/seminars/Linux/commands, and you will see a list of all the commands that we will be running today during the seminar. And then finally, once again, if you have any questions during the seminar or even after the seminar, please ask on cs50.ly/seminars/ed. I'm going to leave this slide for quite a few seconds here, just so everyone can take note if you guys need that. All right. All right. So what is Linux? Most of us probably use an operating system on their computers and laptops like macOS or Windows. Linux is yet another operating system that is free and open source. Now, even though most of us don't use Linux as their main operating system on their computers, Linux is still pretty much everywhere. It's on smartphones, on cars, home appliances, servers, supercomputers, and many more. Now, Linux is also used by so many software developers and system administrators in the industry, which is one of the main reasons why we are talking about it today. Cool. Now, many companies, organizations, and communities take advantage of the fact that Linux is open source and create their own customized versions of Linux, also known as Linux flavors, Linux distributions, or distros for short. Some examples of these are Debian-based Linux like Debian itself and Ubuntu, RPM-based Linux like CentOS and Fedora, Pacman-based Linux like Arch, but there's so many more. Now, Debian, RPM, and Pacman all refer to a format for software packages that you can download and install on each of these distributions. So one of the key differences that you will find between these distributions is how you install software on each one, but they still share the core part of the operating system, so they're going to have so much in common. All right. Now, just like macOS and Windows, Linux has a graphical user interface, or GUI for short, where we interact with the system using a mouse and a keyboard. We, for example, click on things to select them, or double click on files or programs to open them up. We drag and drop things around in order to move them around. We have all of these menus, all of these menu options and and buttons that we can click and interact with. So this is what is known as a graphical user interface, or a GUI. But most of us are probably familiar with that at this point. So today we are going to use a different tool to interact with the system, and that is the command line. So what is the command line? The command line is a way of interacting with the software or system by issuing textual commands. So using my keyboard, I will be able to enter textual commands and run them in order to achieve various tasks. And we'll see many examples of that today. But why would we use something like the command line when arguably something like the GUI is more user-friendly in some cases? And there's a number of reasons for that. But the most important reason is that it's sometimes more efficient and more powerful than using the GUI, allowing us to do things that cannot be easily done using the GUI or cannot be done at all in some cases. Okay, before we talk about the Linux file system hierarchy, let me pause here for a few seconds and see if you have any questions so far on what we introduced. And if you have any questions, definitely feel free to ask in the chat right away. All right, let's move ahead. So the Linux file system hierarchy, or in other words, how files and folders are laid out in a typical Linux system. Okay, I got a question in the chat. What is the difference between Unix and Linux? Unix is also another operating system. It's older than Linux, quite older than Linux, and a lot of what Linux has is actually based on concepts and ideas from Unix itself. So just a completely different operating system that's used that was used before Linux. All right. Is absolutely everything that can be done with a GUI possible with a command line? Yes, pretty much everything that is possible with a GUI is possible with a command line. In fact, there are some things that are possible with a command line that are not necessarily possible with a GUI in some cases. All right. Do we still have Unix? Unix still exists. I don't think it's practically used anywhere, but I think it still exists. It might be used for teaching, maybe. I don't know if there are any other practical use cases for Unix today, because there are more modern operating systems that are more capable of doing things that Unix wasn't capable of doing or wasn't capable of doing as well. All right, let's move ahead. So the Linux file system hierarchy, or in other words, how the files and folders are laid out in a typical Linux system. And it's pretty simple. So in Linux, it turns out that the file system hierarchy looks like a tree of sorts, where everything lives inside of one folder called the root folder and denoted by a /. Now, inside of the root folder, we are going to find some more folder, like we see here, etc, home, user, and opt, and there's more. We might find some files as well. And inside of each of these folders, we can find some more folders and some more folders and files and so on and so forth. And so we end up with this sort of tree-shaped hierarchy that we see on the screen. All right, so it's often the case that we need to refer to the location of one of these nodes on the tree or one of these entries, a file or a folder, to be specific. And for that, we use what is called a path. So what is a path? A path is a bunch of directory names or folder names. So folders and directories are the same thing in Linux. So a bunch of directory names leading up to a particular file or directory that we care about, and separated by /, by /. All right. And there's two kinds of paths. there is an absolute path, starts all the way at the top of the tree, and it doesn't matter where we are in the file tree, it doesn't matter which folder we're in right now, the absolute path for the same file or folder is going to be the same. And there is a relative path, which, as the name suggests, is relative to something. And in this case, it's relative to the folder that we're in right now. So let's actually see some examples of that just to be able to make more sense of it. Suppose we have a file tree like before that looks something like this. And we would like to know the absolute path for the file called mario.c right at the bottom of the tree, highlighted in yellow. Now, the absolute path, as we mentioned, always starts all the way at the top of the tree, always starts with the root folder. So we are going to see root denoted by /. Then we're going to pass by home, Ubuntu, pset1, and then finally mario.c. And so the absolute path ends up being something like /home, /ubuntu, /pset1, /mario.c. The first / represents the root folder, and then every other slash is just a separator between the different folders until we get to the file that we care about. All right, let's take another example. Let's say we would like to know the absolute path of the folder called pset0 on this file tree. Again, the absolute path always starts all the way at the top of the tree. So we'll start with the root folder, /, then we will pass by home, Ubuntu, and then pset folder. So the absolute path ends up being /home, /ubuntu, /pset0. All right. Cool. Now, let's take some examples of relative paths. Now, what is the relative path of mario.c? And we can't just ask this question because, as we said, a relative path is relative to the folder that we're in right now. So we have to say, what is the relative path of mario.c from the current folder, which happens to be Ubuntu, as highlighted in orange in this file tree. So what is the relative path of mario.c from Ubuntu? Now, with a relative path, we don't have to start all the way at the top of the tree. So we just say pset1 / mario.c. All right. So this also happens to be the same thing as /pset1 / mario.c, dot meaning start from the current folder, then go to pset1, then mario.c. So dot just is a more explicit way of saying start from the current folder. All right. Any question on absolute paths or relative paths? All right, what is the difference between / and /root is one of the questions that I saw in the chat. /root is literally a folder called root inside of the root folder, which I get is a bit confusing maybe, but that is literally a folder called root inside of our root folder, which is /. So I hope that answers your question. All right, any other questions on absolute versus relative paths? What if there's a space in the folder name? Well, folder names are allowed to have spaces on them in them. We will not worry about this right now, but when we get to the demonstrations, we will maybe talk about this a little bit more. But that is a good question. So is it okay to write root /home /ubuntu /pset0? No, this is not quite the same. So the word root that I have here at the top is just so we are able to read what this means. But the folder itself is just called /, right? So you're going to have to say /home /ubuntu /pset1 /mario.c. All right, all good questions. Let's take one final example on relative paths that is maybe a bit more tricky. What is the relative path of mario.c, highlighted in yellow at the bottom of the tree, from the pset0 folder, highlighted in orange? Now, we can't just say pset1 / mario.c like we said before, because there is no pset1 folder inside of the pset0 folder. We have to go up one folder to the parent folder, Ubuntu in this case, then go inside of pset1, then reference mari.c. And this notion of going up one folder or going to the parent folder is going to be represented using ... So dot means the current folder, ... means the parent folder, which is in this case Ubuntu, because Ubuntu is the parent folder of the pset0 folder. All right, so ... slash pset1 slash mari.c, and this is the relative path of mari.c from the pset0 folder. Any questions on this one? Do we all get this? Yes, just like this, ... slash pset1 slash mari.c, ... meaning the parent folder of the current folder that I'm in, which is in this case Ubuntu. All right, so this is what I wanted to talk about regarding paths. Let's now jump into an IDE and see what we can do. So first of all, I'm going to go to my IDE at ide.cs50.io. So feel free to open that up if you'd like to follow along with us, and you're highly encouraged to do so. And the first thing that you'll notice is that the CS50 IDE itself has a GUI. So it has a bunch of buttons, a bunch of menus, and all of that that we see in front of us here. This is completely different, completely separate from what a standard Linux GUI looks like. This is just the GUI for the CS50 IDE, which is running on top of a distribution of Linux called Ubuntu Linux. So the CS50 IDE is just a cloud-based programming environment, which means it's a programming environment running somewhere on the internet in the cloud, and it's completely isolated. We are going to use it to demonstrate some commands today, and you're welcome to use it to experiment with anything without having to worry about breaking things on your own Mac or PC. So that should be fine. And the thing that we're going to focus on here is this blue window at the bottom here called the terminal window. So let me go ahead and maximize this so we can focus more on it. And let's start by defining what is a terminal window. And a terminal window is simply a window or a program where another type of program is running called a shell. So a terminal window has another type of program called a shell running inside of it. Now you might be wondering, what is a shell? A shell is simply a program that waits for commands, processes these commands, and then runs them for us. All right? So a shell is going to be the program that waits for commands, processes them, and runs them for us. Now, there are many shell programs available. One of the most popular ones is called bash, the one that's running inside of this terminal window. So this terminal window is running another type of program called a shell, and this shell is called bash. And it's a very popular shell program that we will be using today. Now, notice here on the top left corner, there's $$ We'll come back to what $$ means, but this is known as the shell prompt, and this is where we will be typing our commands today. The shell prompt can be customized. In the CS50 IDE, it is configured to show the path of the folder that we are in right now. And again, we'll come back to what tilde means. $$ is just a symbol that separates my path or the current path from the command that I will be typing, and it's used here by convention. Okay, so the first thing that we're going to do is maybe let's go to the root folder. And to do that, I'm going to use a command called cd for change directory. So change directory space, and then I will say the path that I'd like to go to, the path of the directory that I'd like to go to. And again, directory and folder are the same thing in Linux. So cd space / enter. And you'll notice here on the left that the shell prompt changed from $/ to just /, indicating that the folder that we're in right now is indeed / or the root folder. All right. So what do you think is going to happen if we try to go up one folder from here? What do you think is going to happen if we try to go up one folder from the current folder, the root folder? Not possible, no error, not possible, nothing. Okay, all good guesses. Let's try that out. How do we go up one folder? So again, we are going to use a command called cd to change directory and then mention the path that we'd like to go to, which is in this case up one folder. As we noted earlier, it's represented by ... So cd space ... enter. And indeed, we don't get an error per se, but that was a good guess. But nothing seems to happen. We are still in / as denoted here by the shell prompt on the left. And this is because, as we said, the root folder or / is the topmost folder in our file tree. We cannot go up any more than that. All right, so far so good. Let's see what's inside of this root folder. So let's list some of the directories and files inside of it. And for that, we are going to use a command called ls for list. So ls, enter, lists the contents of the current folder, in this case, the root folder. And don't worry about the different colors and symbols for now. Most of these are just folders. So we're going to take a few of them, for example, to talk about. Let's say the etc folder, for example, is where system-wide configuration files would typically live. The home folder, for example, is where our files and folders would typically live. The opt folder is where third-party software would typically be installed. The let's see, user folder is where some programs and some libraries that are used by these programs and used by the system will be installed. Let's say temp is where temporary files will be installed, and so on and so forth. So all of the ones that I mentioned are, you are pretty much going to find them in any Linux distribution that that you use. And there are conventions about what they are used for, but there's quite a few more folders here that are used for other purposes as well. I see a question in this chat. What is a library? A library is some software or some code that is used by a program. So I'm not going to dive into details about this now. Definitely feel free to check out CS50, and we talk about that in a lot more depth. But that is a good question. All right, let me move forward here. So let's go inside of our home folder and see what's in there. How do we do that? How can we go inside of our home folder from our root folder? So I see cd/home, cd space home. This is good. cd home, correct. What's another way to go inside of my home folder? cd./home. This is the same thing, and also is correct. cd tilde is not quite correct, and we'll know why in a second. All right. How about using the absolute path? How can I go inside of the home folder using the absolute path for the home folder? So I used cd home, I used ./home, cd/home. So this is the absolute path. All three of these are correct, and we will end up being, after I hit enter to run my command, inside of the home folder as denoted by this shell prompt here on the left. Good. Let's see what's inside of our home folder. So I'm going to run ls once again, enter, and there's two folders in here. One is called CS50 and one is called Ubuntu. I'm going to go ahead and go to Ubuntu, and something is different. What is different about this? What happened that is unexpected? Tilde. This changed to tilde, and what did we expect it to be? Right, /home /Ubuntu. Ubuntu, right? But changed to tilde. And it turns out that this is because Linux can have one or more users, can have more than one user, and each of these users would have a username and maybe a password. And some of these users can have what are called home folders configured for them, where each user would have their own home folder to be essentially their workspace, where they would store their own files and folders. Now, in the CS50 IDE, by default, we are logged in as a user called Ubuntu, and the home folder for this user, Ubuntu, is configured to be /home home/Ubuntu. Now, tilde here represents the home folder of the user that's currently logged in. So once again, we are logged in as a user called Ubuntu, whose home folder is configured to be /home/Ubuntu. Tilde, more generally, represents the home folder of the user that's logged in. And so tilde here represents /home/Ubuntu. Now, how do I confirm that? How do I double check that? There's another command that we can use called pwd for present working directory, meaning show me the path, the absolute path for the folder that I'm in right now. pwd, enter, and that will show me indeed that I'm inside of /home/Ubuntu represented by tilde. All right. This might have been a bit confusing for some people. Let's see if we have any questions about this. Yes, is it possible to collapse folders? I'm assuming create folders under tilde. Yes, tilde is just a shortcut for the home folder of the current user. And it's just, it exists because we need to use this path quite often that they made a symbol just as a shortcut for it. So instead of having to type /home/Ubuntu every time to use the absolute path, for example, or if I'm somewhere else, have to write the relative path for my /home/Ubuntu folder, I can just say tilde and it will represent the same exact thing. All right. Cool. What else can we do after showing our home folder? Now let's see what's inside of the home folder right now. So if I press enter, ls, enter to list the contents, I see nothing. And this is because I don't have anything in my home folder just yet. So let's go ahead and change that. Let's go ahead and create an empty file first. And the command to create an empty file is called touch. So touch is the command that creates empty files. And I can say touch space and then the name of the file. Let's say foo, some arbitrary name, enter. And that will create a file called foo in the current folder. So if I do ls again to list the contents, I will see foo created in my folder. All right, what else can we do? How do we go ahead and create a folder, for example? Now, for this, we are going to use a different command called mkdir for make directory and space, and then specify the name of the directory. So let's say we'd like to create a directory called seminar. We'll say mkdir space seminar, enter. Nothing seems to happen. Usually when nothing seems to happen, that is a good sign. It means that the command succeeded. And if I do ls once more, I see two entries, foo, the file that I just created, and seminar, the folder that I just created. So foo, again, yes, is an empty file. It doesn't have any specific file. It's just an empty type. It doesn't have any specific type. It's just an empty file that is created. All right. That is a great question. And this is actually the next question that I'm going to ask. How do you move a file into a folder using commands? So suppose we'd like to move the file called foo that we created inside of my seminar folder. How do I do that? Well, for that, there is a command called mv for move. So we say move, and then the file that we'd like to move, space, the destination, which is the folder that we'd like to move in this case, seminar, enter. Nothing seems to happen like before, but if I do ls again to list the contents, I don't see foo in my folder anymore, in my home folder anymore. Presumably it went into seminar. So let's double check that. It turns out that we can say something like ls space, the name of some folder or the path to some folder to list the contents of this folder. So I can say ls space seminar, and that will show me the contents of the seminar folder, which is, as we see, foo. So just ls lists the contents of the current directory. ls space path to a directory lists the contents of that directory, in this case, seminar. Cool. Are unique names required? That is a good question. Yes, you have to have unique names for each entry in your folder. So you can't have a file, for example, and a folder that are called the same thing. They have to be called something different. Great question. All right. So how do we move several files into the folder? So if you know the names for these files, let's say I have 3 files, foo, bar, and baz, I can list all of them. So I can say mv space foo space bar space baz, and so on and so forth. And then at the end, just enter the name of the folder, and that will move all of these files into this folder. Great question. Are file names case sensitive? Yes, file names are case sensitive in Linux. And folder names as well. So a folder called seminar or lowercase, like we have here, is different from a folder called seminar with an uppercase S, for example. Do we need slash at the end of the folder? No, we do not need slash at the end of the folder name. So I can just do move foo to seminar, and that will have the exact same effect. All right, all great questions so far. Okay, what can we do next? Let's go inside of our seminar folder and see what we can do. So for that, I'm going to use my cd command again. So cd for change directory space seminar to go inside of my seminar. And again, notice the shell prompt on the left changed to ~/seminar because I'm inside of my seminar folder inside of my home folder. If I do pwd, I see the absolute path for my seminar folder like before. If I do ls, I see foo, the file that I just moved inside of my seminar folder. And let's say I don't like the name foo that much. I want to rename this file to some other name, like welcome, for example. How do I go ahead and do this? Now, it turns out that move mv, the command, doesn't only move files and folders into other folders, it also renames them. So I can say move foo, the old name, space, the new name, welcome, press enter. Nothing seems to happen, but if I do ls again, I see that my foo file disappeared, and there is an entry, a file called welcome now that exists. So I managed to rename my foo file to welcome instead. All right. What else can we do with that? Question: Why the slash change in the end of seminar? So by convention, slash at the end of something, slash at the end of something typically means that this something is a folder, but it's optional most of the time. Now this slash is just used as a separator between the folder names on the path. All of these slashes are just separators between the different folders. So for example, if you see here, pwd, once again, this is the absolute path. The first slash, if we have a path that starts with a slash, that means that it's an absolute path. And the first slash just means the root folder. Every slash after this is just a separator between the different folders that are nested inside of each other. All right. Can we move to another directory while changing the name? Yes, you can absolutely do that. So let's demonstrate this and then do it again. Let's say I created another folder called test using mkdir space test. And I would like to move my welcome file to be inside of my test folder, but to have a different name, like bar. I can do move welcome space and then the destination test/bar, and that will have the effect of moving the welcome file from my current folder. But if I list the folder that is called test, I will see that it is named bar inside of it. So I managed to move it and rename it at the same step. Great question. Okay, let's go back to the previous setup. So I'm just going to move test bar to welcome. Back again. So I see my welcome file here, and I'm going to get rid of my my test folder. And this is one way you can remove an empty folder from your system using the rmdir for remove directory. Test, enter. And if I do ls again, I see that my test directory is gone. Let's talk about something that's maybe a bit more interesting. Now, it turns out that any command that I run that has some sort of output ends up writing this output to what is known as the standard output stream, or standard out for short. For example, if I do ls writes back to the standard out the word welcome in this case, and this standard out by default happens to be your terminal. So this is why ls outputs stuff back to my terminal. But it turns out that I can change that. I can have ls output or write its output to something else, some other source, like a file, for example, right? So suppose I want ls to write output to a file called, list, right? I can do that by typing ls space greater than sign list, enter, and I will see that this time ls did not output anything to my terminal because I ended up redirecting where ls should write its output. And in this case, I redirected it to a file called list in the same folder that I'm in right now. So if I do ls again, I see two files. One of them is called list and one of them is called welcome. To view the contents of my file, I'm just going to do cat list, and this is another command that can show me the contents of a file, enter, and I will see that it lists the two entries that are in my folder right now. So this is called output redirection. We can have a command write its output to some other source other than the terminal, for example, to a file. All right. So what else can we do with this? What else can we do with cat? So if I just run cat, what is going to happen? If I run cat and hit enter, nothing seems to be happening, but I also don't get my shell prompt back. Usually when a program is done executing, is finished, I end up getting my shell prompt back. But in this case, it just seems to be waiting for something for some reason. And indeed, it's waiting for input. If I just run cat like this, it's going to repeat everything that I type in. So if I type the word hello, it's going to write back hello to the terminal. If I type the word hi, it's going to write hi back to the terminal, and so on and so forth. Once I'm done entering my input, I can press Control D for done. And that will tell cat, okay, we're done. We're not entering any more lines. You can exit now. And indeed, I see my shell prompt again. Now, how can we use output redirection with this? So we can have cat, instead of repeating whatever I type back into the terminal, write it to some other file, for example. So cat, let's say we want to write to the file called welcome. And again, we use this greater than sign to indicate to cat, don't write output to my terminal. Instead, write it to my file called welcome in the current folder. Enter. Now, if I repeat the same thing, if I say hello, I don't see hello back in the terminal. But if I press Control D to indicate that I'm done entering my input, and then view the contents of the file called welcome using cat as well, so cat space welcome to view the contents of this file, I'm going to see the word that cat wrote to this file, which is hello. So any question on output redirection so far? Yes, we will talk about removing files in a second. If you have data already written in cat, will it automatically transfer it all to the file welcome? Yeah, so when I do this, cat welcome, everything that I type here, enter, hello, hi, enter, is going to be written to the file instead of written back to my terminal. And this is known as output redirection. We redirected the output stream of cat from the default one, which is the terminal, to a file. All right, I'm going to hit Control D once again for done. If I view the contents of this file using cat, that will show me all the lines that I entered. Yes, so the greater than sign in this context means redirect my output. So instead of writing the output to the terminal, write it to a file in this example. Okay, great. So far, so good. What else can we do with this? Let's try this again. Let's try cat greater than sign welcome, still having cat write to welcome. And let's say something like welcome to a taste of Linux. Enter. Control D to indicate that I'm done. If I view the contents of the file called welcome, once again, using cat space welcome, enter, I'm going to see welcome to a taste of Linux. But this is interesting. It seems to have replaced or overwrote everything that was in the file before, which was hello and hi, by the thing that I just entered, which is welcome to a taste of Linux. But what if this is not what I want? What if instead I want cat to append the lines to the file instead of overwriting the contents or replacing the contents of the entire file? How can I do this? Now, it turns out there's another symbol for this, cat, instead of 1 greater than sign, 2 greater than sign. So double greater than sign will append to the file instead of overwriting it. Let's say we want to append it to the file called welcome, like before. Enter. Let's say thank you for joining. Enter. Control D to indicate that I'm done entering my input. Now, if I do cat again on welcome to view the contents of the file called welcome, I'm going to see the line from before, welcome to a taste of Linux, and my new line, thank you for joining. So this is how we can redirect the standard output to a file, but append to the file instead of overwrite it. And this is applicable to any command, not just cat. So any command that has output can, we can do the same thing with it. We can redirect its output to something else like a file. Can we take input from a file? That is great. That is a great question, a great segue to the next thing that I'm going to talk about. So this is known as input redirection, and the whole thing is known as input-output redirection, or IO redirection for short. So we said before that if we run just cat, it takes input from my terminal, from my default standard, standard input stream, or standard in for short, which is my terminal. So I enter all of these lines using my terminal. But what if I don't want that? What if I wanted to take input from a file, for example? And again, cat by default outputs stuff back to the terminal. But what if I wanted to take input from a file and output it to the terminal, for example? So I can do this with the less than sign. So the opposite of the greater than sign. Very intuitive. So cat less than sign, and then the file that I want to read input from. So I'm not going to enter input using my keyboard this time. Cat is going to read input from the file called welcome, and then output it back to the default standard out, which is the terminal in this case. So if I do that, enter, it shows me the 2 lines that this file has. So it read the contents from this file and then outputted them back to the terminal. So this is input redirection. Now, you might be wondering, can I do both? Can I redirect input and redirect output to some files? And the answer is yes. And we can do this using something like this. So suppose I want to read input from the welcome file and write the output, not to the terminal, but to a file called welcome1. How can I do this? I'm going to write cat less than sign for redirecting input, read the input from welcome instead of my terminal, then write the output back to a file called welcome1. And if I do this and hit enter, nothing seems to happen. Like before, this is a good indication. And nothing seems to be written to the terminal. So cat did not write anything to the terminal this time and did not read anything from the terminal this time. But if I do ls, I'm going to see my welcome1 file in addition to my welcome file. And if I do cat on welcome1, it will have the exact same contents as the welcome file, because cat ended up reading the contents from the welcome file, then writing it back to welcome1. Any question about input or output redirection? Cat is short for concatenation, right? Yes, cat is short for concatenate or concatenation. And this is also one of the things that cat can do. You can list a bunch of files. So you say cat welcome, welcome1, for example, and that will end up concatenating all of these files. So printing all of their contents one after the other. So because these two files have the same contents, it's printed twice. But you can imagine redirecting this output to some other file. It's called let's say test, for example. Enter, and now test is going to have the concatenated result of welcome and welcome1. So this is another use case for cat. Good question. All right. Now, this is what we ended up doing here by creating this welcome1 file, is that we really ended up copying the file. But this is not necessarily the best way to copy a text file or to copy a file. There's a separate command for this called cp. And cp copies one file to another. So if I want to copy the file called welcome to welcome2, I can do cp space welcome space welcome2, enter, and do ls again to list the contents. And that will end up showing me that welcome2 is created down here. If I do cat on welcome2 to view the contents, I will see the exact same contents that were in welcome. So cp ended up copying my welcome to a new file called welcome2. All right. Now, what else can we do with this? Now, I definitely don't want 3 copies of my file called welcome. So how can I remove a file? We saw how to remove an empty folder earlier using rmdir. How can we remove the file called welcome1, for example? Now for this, using we're going to use a separate command called rm for remove. So rm space welcome, the path to the file, relative path to the file in this case, welcome, enter, and it's going to ask me, remove regular file welcome. And I can type in here yes or y for short and press enter. And now if I do a list again, my welcome file is gone. So I managed to remove my welcome file using rm. But what if I'm absolutely sure that I want to remove this file and I don't want to get prompted whether or not to remove the file for confirmation? I can do this using rm space -f. Let's say I want to forcibly remove the file called welcome2 without getting prompt to confirm. Enter. Nothing seems to happen. If I do ls once more, I see that welcome2 is now gone. Now, this is pretty dangerous though. So if you do this, if you remove something forcibly, as the -f indicates, you have to be careful because you can end up removing files that you didn't mean to remove. So this -f part is kind of interesting. This is known as a command line option, or just an option for short. And pretty much all of the commands that we're going to use today are going to have some options that influence or change the behavior of the command itself based on what options we provide. But how did I know about the existence of something like -f? Now, it turns out that most of these commands have a special option called --help. So if I run a command, then say space --help, this is going to give me a somewhat short description of what the command itself does and what are some of the options that are supported. So if I look at this description, I see that -f or --force is used to ignore non-existent files and arguments and never prompt me before every removal. So this is what -f means, and this is how I knew about, no, actually, so yeah, just the first line. So -f force, ignore non-existent files and arguments and never prompt. This is what -f means, and this is how I figured out how I could do this. So --help is a special option to many of the commands that we'll be using today. If you'd like more detailed information about the command and more detailed information about the options, you can use what are called the manual pages or man pages. So it turns out there's another command called man for manual. We can say man space and then the name of the command that we'd like to know information about. And most of these commands will have some manual pages. Say rm, enter, and that will open something else with more details here that we can scroll through and more information about the options and maybe some examples of how to use the command and so on and so forth. So these are known as man pages or manual pages, and they exist for most of the standard Linux commands that we have. I'm going to press Q to quit this. Now, what if I want to do something, but I don't quite know what command to use? So aside from looking things up on something like Google to see how you can do something, you can also use man. So you can do man -s1. So -s is an option of man that I knew by reading the manual page for man or the help for man. -k for keyword, and then let's say remove. Now -s here means I want to look this up in the manual page section 1. So there, it turns out there's multiple sections, multiple manual page sections, and section 1 is the one that has manual pages about the general commands that we use. So I'm going to search inside of section 1, and I'm going to search for the keyword remove. Show me what you got. Enter, and this is going to show me a list of results. Among them is RM, and it's used to remove files or directories. This is what I want, so I can just use RM directly if I know how to use it, or I can see the help or the man page for RM and then use it. It also shows me rmdir, which removes empty directories, and we used earlier, and a bunch of unrelated results as well. So this is how you can discover some of the commands that you can use if you'd like to know something, if you'd like to do something and you just want to search by keyword, how you can do it. Kind of weird question, how do we know which section we are looking for? So there are predefined sections. I don't know all of them off the top of my head, but there's about maybe 7 or 8 sections that you can look them up online if you Google manual page sections. And section 1 is for general commands. You're going to find section 2, section 3 for other things like system libraries and so on. But yeah, this is how I knew that I should be looking in section 1. I can certainly look in all sections if I do something like man-k remove, but this is going to show me a lot more results, as you can see here, because it's all of these numbers in parentheses are section numbers. So it's going to show me things from section 2 and section 3, which are not necessarily commands that I can use. Great question. -k is, what does -k mean? A question in the chat. -k means keyword. So I'm filling man page to search the manual pages for this particular keyword, which is remove. All right. Any other question about man pages or any of the commands that we used before? Okay, let's switch to our first activity for today. Going to share back my slides on activity 0. And in this activity, we are going to do 4 things. We are going to create a directory called activity 0 in our home directory, tilde, or /home/Ubuntu. Number 2, we are going to change the current directory to the activity 0 directory. Number 3, we are going to write hello world to a file called hello in this directory. So maybe use something using something like cat. And number 4, we are going to print the contents of the file called hello to the terminal. I'm going to give you 5 minutes to work on this. If you would like any hints or would like to take a look at some of the commands that we ran so far, you can go to cs50.ly/seminar/linux/commands, link here on the screen. And if you have any questions, definitely feel free to ask in the chat or on the ed discussion forum at cs50.ly/seminar/ed, also linked here. So with that, I'm going to give you 5 minutes and then we'll come back. All right, welcome back, everyone. Let's go ahead and walk through a solution for this activity. And if you haven't figured it out yet, don't worry. We're going to walk through a solution here. So feel free to follow along with that and see what you can do. So the first thing that we need to do is create a folder in our home folder, which is tilde or /home/Ubuntu. So maybe the first thing that we need to do is to go to our home folder. How can we do this? What command do we use? All right, I see cd ... That is correct. cd tilde, that is also correct. It turns out that cd as well works by itself. So by default, cd will take me back to my home folder as well, which is quite handy. So cd ... will take me back to my home folder. cd tilde will take me back to my home folder, and just cd will take me back to my home folder. If you notice here, cd space dash is also a shortcut that goes back to the previous folder that I'm currently in. So I was previously in seminar, then I switched to my home. If I do cd dash, that will take me back to seminar. So cd space dash or minus takes me back to the folder that I was in before. All right, so I'm going to go back to my home folder using cd. Now, the next step is to create a directory called activity0. How do we create a directory called activity0? What command do we use? Make dir space. Now, touch is not used for creating files. It's not used for creating directories. It's used for creating files. So touch would not be correct here. Make dir is correct. So make dir activity0 is going to create a folder called activity0 in the folder that I'm in right now. If I do ls to double check to list the contents, it's going to show me the two directories that I have, activity0 and seminar. Now, I can go inside of my activity0 using what command? cd space activity. That's not going to work because the name does not exactly match. There is no folder called activity. We have to do cd space activity0. Oops, activity0. Enter, and you'll notice that my shell prompt changed to activity0. So I'm now inside of my activity0 folder. Now, the next step is to write hello world to a file called hello. How can we do this? Cat greater than sign hello, or touch hello in the beginning. Now, it turns out that if you redirect to a file that doesn't exist, by default, it will be created for you. So we could do touch hello and then cat to this file, but we can just do directly cat to hello. Okay, so cat to hello. And then I'm going to say hello world, enter. What do I do to indicate that I'm done with my input? Control D for done, that is correct. And then finally, how do I view the contents of this file? Cat space hello. Actually, let's double check first that the file was created. So if I do ls, I see hello file now. The hello file now exists in my activity0 folder. If I do cat space hello, oops, not welcome, hello, that will show me the contents of the hello file, and it says hello world. So great, very well done. All right, the next command that I wanted to show you is a command called wc for word count. And this command, if I run it just by itself, asks me for input just like cat does. If I give it some input, let's say foo, bar, baz, box, just a bunch of random input, and then press Control D to indicate that I'm done, is going to show me somewhat useful information about my input. It's going to show me the first is the number of lines, and I know that by reading the man page for WC. So we have 3 lines. we have 4 words. So the second part of the output is 4, which is 4 words. And the third part of the output is the number of bytes that I entered. So the size of the file, which is 16 bytes in this case. All right. So this is what, this is what WC does. Now, it turns out that there's an option for WC if I want, for example, to see only the number of lines that are in the input. So if I do WC, and this option is -L or -L, enter, and if I enter the same thing, foobar, as quax, enter, and then Control D, that will only show me 3, which represents the number of lines that I have entered so far. So what else can we do with this? Now, it turns out that there is another form of input-output redirection called piping or pipelines or pipes for short. So let's go back to a previous example. So let's go back to our seminar folder, which exists in my home folder. How do I go back to my seminar folder? So CD takes me back to my home folder. CD ~/seminar would work using the absolute path for my seminar folder. All right, so I'm going to do that for now. I could have also used /seminar, go to the parent folder, and then go to seminar. Or I could have used .. first and then CD into seminar in 2 steps if I wanted to do that in 2 steps. All good guesses. Great. So right now I'm in my seminar folders, and these are the files that I have. Now, it turns out that I can do this. I can do cat welcome1 to see that I have these lines in my welcome1 file. I can do cat welcome1, then the vertical bar sign or symbol, which exists typically near your enter or return key on a standard English keyboard. So vertical bar, WC-L. So what does this do? What this does is it says print the contents of this file called hello1, but instead of printing it to the terminal, have it consumed as input by the second command after the vertical bar, which is WC. And the effect of that is just counting the number of lines that are in the file, which is 2, as we see here. So once again, piping is another form of input-output redirection. I can have a command write output that is consumed by another command as input, and then this command can output something useful for me. So I can chain these commands. I can chain 2 or more commands. So if I have a command called if I have a command called A, B, and C, I can chain them like this. So that means run A first, and whatever A outputs, have B consume it as input, and whatever B outputs, have C consume it as input, and so on and so forth. So this is what is known as input-output redirection, and this is how we did it before. All right, any question on pipes? Now, why use a pipe instead of greater than sign? That is a great question. And the answer is that with greater than sign, we end up redirecting our output to a file. With pipes, we don't really need to do this. We can just have the program that comes after the vertical bar consume the other program's output, even if we don't have a file. So let me give you an example of that. We said before that if we run just cat, everything that we typed is just written back to the standard out, which is by default the terminal in this case. So hello, hi, all of that, right? Now we can do this. We can do cat vertical bar WC-L, enter, and that will ask me for input. I'm going to say hello. Notice that it's not outputting anything back to my terminal. Hi, how are you? Nothing is being outputted to the terminal. But once I hit Control D to indicate that I'm done with my input, it's going to print the number of lines that I have entered. So I did not create any files here. I just had the output of the cat program, which would typically be written to the terminal by default, be consumed as input by the WC command, and that outputted the number of lines, which is 3. All right. So yes, we can, in this case, we chained just 2 commands in our pipeline, but we can have more than 2 commands in our pipelines if we wanted to. Great question. So this is piping. In simple terms, let's next do something maybe a bit more interesting. Let me go back to my home folder using CD. And I'm going to download a file from our CDN using a new command called wget. So wget takes a URL for maybe a file or something and downloads this file to my CS50 IDE in this case. So I'm going to do this. I'm going to download this file, which I know the link to off the top of my head, cdn.cs50net/2021/x/seminars, I think, /linux/shows.csv. And this is also in the slides if you'd like to copy that instead of having to type it out like that. So this is the file that I'm going to download. All right. Enter. And I see a bunch of output here that indicates that the file seems to have been downloaded successfully. So if I do ls to confirm that, I can see that a file called shows.csv was downloaded inside of my home folder. Okay. So let's view the contents of this file first. So to do this, I'm going to do cat shows.csv. And a bunch of output is going to fly by my terminal. There's so many lines. This is just a file containing a bunch of TV shows and movies from IMDb with their IDs and titles and the year that they aired in, the number of episodes and more. And this is known as a CSV file or comma separated format because each one of these lines has a number of fields that are separated by commas, as we can see here. Right, so the ID is first, then comma, then the title, then comma, then the year, and so on and so forth. So this is what a CSV file is for comma separated values. All right, but this is not the best user experience really. If I want to, view the contents of this file, but also do some stuff with it, like scroll up and down pretty easily, or search for something, or stuff like that. So for that, we can use a different command called less. So less also shows me the contents of the file, but it lets me interact with the file in a more meaningful way, perhaps. So less, the path of the file shows.csv, enter, and that is going to open this file from the top like this. So we see the first line here represents the header for the CSV, the headers for the CSV, or the names for the columns in the CSV. We see the ID, title, year, episodes, and so on. And then each one of these rows represents one show or movie. All right. So the first thing that we can do with less is scroll down by one line. If we want to scroll down by one line, we can just hit the J key on our keyboard. So J will just scroll down line by line, as we can see here. If you'd like to scroll up, we can press the K key on our keyboard. So K will scroll back up line by line. But this is a bit boring. If I just take a glance at this page and see that nothing is interesting in here, I'd like to be able to scroll to the next page without necessarily having to scroll down line by line. And for that, there is also a keyboard shortcut, which is space. So if I hit the space bar, it's going to jump immediately to the next page, space bar, next page, space bar, next page, and so on and so forth. Now, if I want to go back to the previous page, I can hit B for back. So B goes back to the previous page, back to the previous page, and so on and so forth. Now, suppose I ended up scrolling down a bunch of pages, and I'd like a quick way to go back all the way to the top of the file. There's also a shortcut for this, which is G. So the letter G, if I press G on my keyboard, it's going to jump all the way back at the top of the file. And by no means do not try to memorize all of these shortcuts. There's definitely a list of them somewhere that we can look up and see. And over lots of use and lots of practice, you'll just know these things off the top of your head. So G takes me back to the top of the file. If I want to go down all the way to the bottom of the file, I can press Shift G, and that will take me all the way down to the bottom of the file. And you can see here that less says, hey, this is the end of the file. I cannot go down any more than this. All right, so this is G, and Shift G to go down. Now, let me jump back all the way to the top using G. Suppose I want to search for something in this file. So suppose I want the shows that have the word the in them. For that, I can press the / key on my keyboard. You'll notice here at the bottom of the screen that the colon changed to slash, and I can start typing the thing that I'm trying to search for. So the word the, for example. Enter, and it will jump right away to the first finding if it did find one. And apparently the first show that has the word the in it in this file is called Rock from the Sun. Now, to jump to the next match, if there are more matches, I can press N for next. So N will take me to the next match, N to the next match, and so on and so forth. Now, if I want to jump back to the previous match, I can press Shift N. So Shift N will take me back to the previous match, Shift N again will take me back to the previous match, and so on and so forth. Now, if we keep hitting next or N, you're going to notice that this includes even the as part of a word, not the on its own. There are ways to work around this as well. But if you'll notice that all of these matches are exactly matching the case of the word that I entered, lowercase the. What if I want to search this in a case insensitive way? So don't care about the case, just search for the letter the, whatever they are, uppercase or lowercase. So for that, I can press -I, and you can see here that the prompt at the bottom changed to ignore case in searches. Now, if I repeat my search, press next, and you can see now that some matches with an uppercase T started to come up. All right. Now, once I'm done using less, I can just press Q to quit the less program, and I get back to my terminal shell. Right. So this is a bunch of shortcuts, and there's many more shortcuts that you can use inside of less, and it's a handy way to view the contents of the file in a maybe more interactive way. So the default, how to check non-case sensitive. So we press -I. So if I show this again, if I press -I, that will toggle whether or not I'm searching in a case sensitive manner. Again, start the search with pressing /. So / and then the search that I'm looking for. Enter, and that will jump to the first match if it found one. Can we search for a certain sentence instead of just a word? Yes, you can do that. So if I say, Game of Thrones, for example, that will show me the first match that matches Game of Thrones. Now, if there are some tricks here, so if your search term, for example, has a / in it, that might confuse less a little bit, so you would need to escape that, but I'll leave that for another demo. Okay, so that was less. Pretty handy tool to interact with files. Now, this file is pretty big, as we saw. What if I just want to view, the first n lines of the file, the first few lines of the file? How can I go ahead and do this? Now, for this, there is a command called head. To do that, so head space, the name of the file or the path of the file, enter, and that will just show me the first 10 lines or so from the file. And I can change that. I can change it to, head using the option -n for specifying the number of lines, 28 shows.csv, enter. And that will show me the first 28 lines of the file instead of just the first 10. So head can be used to view the head of the file. In other words, view the first few lines of the file or the first number of lines, however you specify. And notice that this can be also useful for piping stuff. So if you have a command that outputs a number of lines and you just care about the first few ones, instead of having your terminal scroll all the way down and not be able to see the output properly, you can use head and use piping in order to avoid this. For example, let's say cat shows.csv like before. You saw that the output, the entire file flew down, all the way down to the bottom. But suppose I just care to the, so the output of the cat file is all of these lines, but suppose I care about just the first like n lines, the first 10 lines in the file. I can do cat shows.csv, pipe into head, so take the output of cat, whatever it is, then consume it as input by head, and then head will take that input and just show me the first 10 lines from the file. Or if I want more, I can do -n 20, and that will show me the first 20 lines from the file, and so on and so forth. So this is the command that we use here, cat shows.csv, vertical bar for piping into head, and then head will do its job. Now, what if we want to do the opposite? What if we care about the last n lines of the file? For that, we can use a different command called tail. So the opposite of head, so tail shows.csv just shows me the last 10 lines or so from the file. And in the same manner, we can do tail-n 20 or 28 or whatever shows.csv, and that will show me the last 20 lines from this file. Could we just use head shows.csv? Yes, you can use head shows.csv, and that will have the same effect. But suppose that you have a command, not necessarily a file. Suppose you have a command writes output to the terminal, for example, to the standard out, and this output is pretty long, and you just care about the first n lines from this output. You can just run this command, right, whatever it is, and then pipe it into head, and head will take the output of this command and just print the first 10 lines or so from the file, or however you specify. Good question. Yes, indeed. That's a good question. If we want to write the first 10 lines to another file, can we do that using head and redirection? Yes. The way to do this is going to be head, shows.csv, and let's redirect the output using the greater than sign like before. Then the name of the file first, for example. So that will write the first 10 lines from shows.csv. Instead of writing it to the terminal, it will write it to a file called first. And notice that head doesn't write anything to the terminal. If I do ls, I see a file called first now in my current folder. If I do cat first, I see just the first 10 lines from the file. Great question. Any other questions about head or tail before we move on? All right. We can also do something like wc. So wc-l on shows.csv, and that will show us, for example, the number of lines in this file, which happens to be 500 in this case. But let's do something that's a bit more advanced maybe than this. Now, like I said before, if we open this file using less, this file is a CSV file for comma separated format, and each of these lines represents a movie or a show, except for the first one. And each of the fields in each line are separated by commas. What if I just care about, the first column in this file instead of the whole lines? So what if I just want to print the IDs out instead of the IDs, the title, the episodes, the year, and so on? Well, for that, I can use a command called cut. So cut is a command that will let me select specified fields from the file and print them out. Now, I have to specify the delimiter that separates these fields. So for that, I'm going to use the option -d, and I knew this from reading the documentation or the man page for cut. So -d, and the separator that I'm using is comma, because this is a comma separated values file. Then I'd like to print the field number 1, which is the ID field, from the file called shows.csv. So the command is cut -d for the delimiter or the separator, which is going to be comma in my case. Then I just care about the field number 1, the first field, which is the ID column here, right? From shows.csv, if I press enter, I'm going to see nothing but IDs in this output. Maybe the first column for the first line as well. But as you can see, it did that. We can do the same thing for shows. So for the show title. So for example, if we open the file, we find that the show title is the second column here. So we can do the same thing, cut -d, comma, separate by commas. Then I care about the second field instead of the first one, shows.csv. And that will show me all the titles of the movies and the shows that I have in this file. All right. I can do that for multiple fields. So suppose that I'd like to print the title of the show and the year that it aired. And I know that the title of the show is the second column, the year is the third column. I can do the same thing, cut -d, comma, -f for the fields that I'd like to print. And then 2 and 3. So I'd like to print the second field and the third field, the name of the show and the year, shows.csv, enter, and that will show me the title of the shows and followed by the year. Okay, any question about cut? So this is how we can use cut to select certain fields from the file to print. And again, we can pipe this into any, into some of the tools that we talked about today, like head. So if I care about the first 10 lines from this output, for example, I can pipe it into head, and it will show me the first 10 lines from the output instead of the whole thing. Is using -f in cut compulsory? Let's try this out. I actually don't know. I think it might end up printing the whole thing. Let's see. If we remove -f, oh yes, turns out it's required. It's required to specify fields. Again, this is one of the advantages of using the CS50 IDE for something like this. It's completely isolated. You can freely experiment with that without having to worry about breaking anything on your own Mac or PC. That's a good question. Okay. Any other questions about cut? Say the columns were separated by a colon, the limiter would be a colon? Yes. So if the fields were separated by the colon symbol instead of the comma symbol, I'm going to say -d colon. Now, some of these symbols might confuse your bash shell, so you might need to surround them in single quotes like this. So that will be safer. Great question. All right. Let's move to the next tool. Now, I don't like the fact, if I open this again in less, I don't like the fact that these IDs seem to be randomly sorted in a way, right? What if I'd like to sort this file by these IDs? Now for this, there is a command called sort shows.csv, and that will print sorted output. But if you notice, there's something weird about this. By default, notice that like sometimes there are smaller numbers that come after bigger numbers, and that doesn't make sense. And this is because by default, sort compares these strings or these numbers by the value of the representation. So if they're represented in something like ASCII or something, so you'll find that all ones come first, and then all twos become first, and then all ones come first, and then all twos, and then all threes, and so on and so forth, which is not quite natural for us. This is not what we really meant by sort. We want sort to be able to sort this file by the numeric value of this string, not by the representation, right? So to do this, if I read the documentation for sort or the man page, sort-n, the option -n does that. Does exactly that. Uses the numeric value to sort the input. Shows.csv, enter, and I can see now that the IDs are now sorted more properly, the way that I want at least. All right. So this is how you can perform sort on a file. Notice if I open the file again using less, the file is still not sorted. So what happened is, like before, sort did not change the contents of the file. It just wrote the output to standard out. If I want to store the sorted output in a file, what would I do? What command or symbol would I use? Greater than sign, that is correct. So sort -n shows.csv, and let's redirect the output instead of the terminal to a file called shows_sorted.csv, for example. And that will have the effect of having sort write its output to this file instead of the terminal. If I hit enter, nothing seems to be happening in the terminal, which is great because presumably sort did exactly that and wrote all the output in shows sorted. If I do ls, I found a file called shows_sorted.csv. And if I do less on shows sorted.csv, I find that the sorted output exists in this file. All right. Great. Now, can we sort by other fields? Yes, you can sort by other fields. I let you explore the man page for sort to figure out how to specify different fields for the sorting. Can we write sort in the file itself? Now, this is a bit tricky. I don't think sort supports this by default. But it's quite dangerous if I try to redirect the output to the same file. I can risk losing some data because the sort program, would be trying to read the lines from this file, but also write lines to it. So it might end up overwriting lines. And so it's quite dangerous to do this. So what most people would do in a situation like this is just write the output to a temporary file and then overwrite the original file by renaming the temporary file to the original file. So using the mv command or something, you can achieve something like this. All right. Good question. What's next? Now, suppose that I would like to search for something in this file without necessarily opening it and scrolling through it. How can I do this? Question in the chat, how do I rename a file? You rename a file like we showed earlier using the mv command. Yes, correct. All right. So how can I search for something in the file without necessarily opening it and scrolling through it? And for that, we use a command called grep. So grep, then the thing that I'd like to search for, so let's say friends shows.csv, enter, and that will print out the line that has the term friends in it to my standard output. All right. Notice if I do grep friends shows.csv, it does nothing. It finds nothing. And this is because, again, search by default is case sensitive. So if I want to grep to ignore the case, I can do grep -i for ignore the case. Friends, I can enter friends in any case that I want. Shows.csv, enter, and that will end up finding me the same output. Now, can I search for something like a sentence? Yes. So I can do the same thing. Grep, -i, Game of Thrones. And notice that I put this inside of quotes because I want grep to search for this as one thing. And there are spaces. So if you have spaces or special characters in some of these arguments, you will need to surround them with single quotes or double quotes. So search for Game of Thrones, ignore the case inside of shows.csv, and that will show me information about Game of Thrones from this file. Right? Now, you can use regular expressions with grep as well. If you're familiar with regular expressions, we're not going to spend time talking about regular expressions in this seminar, but you can do something like, show me all the lines that start with 28. So the caret symbol in regular expression means the thing that starts with the following, which is 28. So start with, search for anything that starts with 28 in shows.csv, enter, and that will show me all the lines from the file that start with 28, like this. All right, so we can use regular expressions with grep as well, which is quite handy. So we don't have to provide the exact thing that we're trying to search for. We can just provide some sort of pattern, and grep will try to match this pattern and find the results for us. Now, I found myself doing grep-i over and over, and I wanted, to make it simpler for myself. So there's a command called alias that allows me to alias a command to another. So let's say I want to alias igrep to grep-i. So that means that in this terminal window, whenever I type igrep, I really mean grep-i. So I can do this and search for friends, for example, inside of shows.csv, enter, and that will run grep-i for me, find friends, ignore the case, and show me the results. Okay, so this is alias. Now, one other command that I wanted to show you is the history command, which is pretty useful. So one thing that I didn't mention, and I should have probably mentioned earlier, is that if I press up, the up arrow key on my keyboard inside of my terminal, I scroll through the commands that I entered, starting by the most recently entered command, and then the one before that, the one before that, and the one before that. And I can press the down arrow on my keyboard to scroll down. So this is quite handy if you want to enter the same command over and over again, but you just don't want to type the whole thing. You can just press up a bunch of times, and it will scroll through the command history and show you these commands. You can also search this history by pressing Control-R. So if I do Control-R and enter something like G, it will find me the commands that have G in them. I can press Control-R to scroll through them. And then once I found the one, I can just press Enter, and that will run it for me. How long does alias remain active? So alias remains active during this terminal session. There are ways to persist it, but we're not going to talk about it in this session. But if you create an alias in this terminal window, it's going to be only for this terminal window, and it's going to persist throughout this session. Good question. Now, the next command that I want to show you related to pressing up and down on my keyboard is the history command. So if I run history, I will see all the commands that I entered so far. This is a list of my command history, one after the other. And again, if I care about the first 10 commands that I enter, I can do pipe into head, and that will show me the first 10 one. If I care about the last 10 ones, I can do pipe into tail, for example, and that will show me the last 10 ones that I entered, including the piping that I just did. So this is history. And then the last command that I'm going to show you is a command called find. So it's often the case that you would like to find a certain file or folder in your file system on your machine. And to do that, we are going to use the command called find. So find, and then the folder that I'd like to search inside. So let's say we want to search for any file that starts with CS50 in the /user folder. So find space /user, then -name for specifying the name of the file, space, and then specify the name of the file. So I'm just going to say anything that starts with CS50 and ends with anything. So long as it starts with CS50, I'm fine with that. So again, find inside of my user folder the files that are named that start with the name CS50. Enter, and find will take a second, and then it's going to print out all the files inside of my /user folder that start with CS50. So CS50.h is one example. There's a folder called CS50 here. There's a file called CS50.py here. There's a file called CS50.jar here, and so on and so forth. So this is how we can use find to search for files and folders by their names or using some sort of pattern. Again, if you'd like more information about find, go ahead and run man find, and that will show you more detailed information about find itself and about the options that you can use to refine yourself better. Now, one command that I missed, that I forgot to talk about earlier, is actually sed. So let me go back and visit this real quick. So when I was working with this earlier, I noticed that one of the shows, if I search for Seinfeld, I actually do this using grep. So if I do grep-i or igrep using the alias that I created, igrep sign for Seinfeld, and then in shows.csv, I get this mesh. I noticed that this is misspelled. Actually, I did create this misspelling on purpose just to demonstrate this. So this is misspelled, and I'd like to fix this misspelling in the file without necessarily opening the file in an editor and fixing this. So how can I go ahead and do this? For this, I can use a command called sed. So sed allows me to replace parts of a file based on a pattern that I provide, right? And the syntax for sed is quite overwhelming at first glance. Frankly, it's quite overwhelming all the time. But we can do something like sed s slash the thing that I'd like to replace, Seinfeld, which is misspelled, with the fix Seinfeld, which is the correct spelling, slash, and then close my quote, and then specify the file. So let's go through this once again. Sed s slash replace my Seinfeld, which is the misspelled version, with the term Seinfeld, which is the correctly spelled one, inside of the file called shows.csv. Now, let me pipe the output through less. And if I search for Seinfeld again, I will find that it's spelled correctly. I can actually pipe the output to igrep like before. So igrep sign, and that will show the correct spelling of the term that I replaced here. But the file itself, shows.csv, does not change. So if I search for Seinfeld, Seinfeld, it's still misspelled here. So if I would like to fix this in the file itself, we can do, as we said before, we can redirect the output to a file and then rename that file to shows.csv. So we can do something like, redirect the output to shows_fixed.csv, and then move shows_fixed to shows.csv, and that will fix it. Or turns out sed itself has an option that allows you to replace stuff in place, which means in the same file. And this option turns out to be -i. So sed-i s Seinfeld with Seinfeld, the correct spelling, slash, and then do that replacement in my shows.csv file. Press enter. Nothing seems to happen. But if I open, or if I grep for sign in Seinfeld again, I'm going to see that the typo was actually fixed. All right, so this is how we can use sed. Any questions about sed or grep or find or any of the commands that we talked about so far? What did sed-i do? So by default, sed does not replace the contents of the file. It just prints the output to the standard out. -i tells sed to instead do the replacement in the file right away. So sed takes care of writing the output to a temporary file and then presumably moving the file to the original name to overwrite it. Good question. All right, let's take our last activity for today, activity 1. And in this activity, we are going to do 5 things. We are going to create a folder called activity 1 in our home folder, like we did before. we're going to change the current folder or current directory to activity1. We are going to download this shows.csv file, maybe using wget. Number 4, we are going to use a pipe to print out to standard output to the terminal what year did Mr. Robot air in. And then finally, number 5, we are going to find the location of the file called libcs50.a, maybe using find. So let's go ahead and work on this activity. Definitely feel free to check out the commands that we've entered so far if you'd like to take any hints at cs50.ly/seminars/linux/commands. And if you have any questions, definitely feel free to ask in the chat or on the ed discussion forum at cs50.ly/seminars/ed. Let's take 10 minutes to work on this, and then we'll come back to wrap up. All right. Welcome back, everyone. Let's work on a solution for this. It's quite okay if you haven't figured it out. It can be very tricky at first, but definitely feel free to follow along with us, and let's see what we can do. So step one, we need to create an activity1 folder in our home folder. How can we do this? So first of all, we need to go to our home folder if we're not in it already. How can we do this? How can we go to our home folder if you're not inside of the home folder? CD or just CD, CD tilde or just CD, that will take me to the home folder. I just happen to be inside of the home folder already, so that's fine. What command do I use to create a directory called activity1 for step one? Mkdir, just mkdir activity1. Yep, that is correct. So mkdir activity1, that will create a directory called activity1 in my current directory, which is the home folder. If I do ls, I see that activity1 is now listed in the list of directories and files in my home folder. How do I go inside of activity1? Yep, everybody's typing activity cd space activity1. That will change my current directory to my activity1 directory, and you'll note this change in the shell prompt here on the left. Now, what is the next step? Download the file called shows.csv. So for this, we are going to use a command called shows.csv. So we can use wget like before, https://cdf.csv.net, and then the whole URL. Yep, we can do that. But I actually know that shows.csv is also in my home folder, I believe. Yes, so it's right here. What if I want to copy this? Let's do something different here. What if I want to copy this from my home folder, because I know it's going to be the same file that I downloaded before. So what if I want to copy this from my home folder inside of my activity1 folder? What command would I use for this? What command would I use to copy the shows.csv file inside of my activity1 folder? cp ... because shows.csv is in the home folder, so it's up one folder. So ... / shows.csv space. So I can't say activity1 here because I'm already inside of my activity1 folder. How can I say copy it here inside of the current folder? What symbol represents the current folder? Dot. So I can do dot, and that will copy shows.csv from the parent folder into dot, which is the current folder. Enter. Nothing seems to happen, but if I list the contents of this folder now, I see that I have shows.csv. All right. The next step is that we would like to print the year that Mr. Robot aired in to the terminal. How can we do this? Let's take this step by step. How can we find Mr. Robot in the file called shows.csv without necessarily opening the file and scrolling through it? So a bunch of people are saying grep. So grep Mr. Robot, and if I want to ignore the case, I can use -i. In this case, I happen to enter the case correctly. Shows.csv, enter, and that will get me the line that matches my search term, which is Mr. Robot, with every field in it. Okay, so I found the match that I care about. How can I print the specific year, which comes in field 1, 2, 3? Yes, so I can pipe the output of grep. So instead of having grep print the output to the terminal, I can have this output be consumed by a command like cut. I'm going to use the delimiter or separator, comma, and I care about the field number 3. So this is the field number 1, field number 2, field number 3 after the comma. So field number 3, enter, and that will show me 2015. Cool. This is pretty cool. All right. The final step is how do we find a file called libcs50.a inside of my user folder, inside of my /user folder? And for that, we are going to use a command called find, as people are noting in the chat. I want to search in my /user folder, but this can be different. This can be any other folder. In this specific case, we explicitly said that we want it to be, we want to find the match that's inside of the user folder, /user folder, right? Then minus name, here's the name that I'd like to search for, and then something like libcs50.a, and this will show me the path for the CS50 library inside of the CS50 IDE, which is /user/lib/libcs50.a. All right, great work. Yes, so yeah, no need for stars or quotes in this case. I can have quotes just to be safe. If you have any special symbols or spaces in the search term, you will need to surround it by quotes. I guess it's always a good practice to surround things by quotes, but just for the sake of simplicity, I didn't enter quotes here. And in the previous example, star meant match anything that comes after CS50. So when you search for CS50 star, we meant search for anything that starts with CS50, then has anything after CS50. So that ended up finding things that not only has CS50 at the beginning of their names, but more stuff as well. All right. Can the name of the directory have quotes? I think it can, but we might need to escape these somehow. What is the difference between star and the caret symbol, which is like this little up arrow symbol? For regular expressions, no. So this is different. So the caret symbol in regular expressions means the string that starts with something. So if I say caret foo, it means the string that starts with foo. This star is also used for regular expressions, but it's used. It has a slightly different meaning. For find, star just means match anything. Good question. Yeah, I don't think it's a good practice to have quotes in file names and folder names, but I think it's possible. Cool. All right. Before we wrap up, I wanted to share a couple more links with you. So certainly you can feel free to experiment more with the CS50 IDE, which is again running Ubuntu Linux, but it's a more restricted version of Ubuntu Linux. Because again, CS50 IDE is really designed to be used for classes like CS50 and the like. If you'd like a more complete version of Linux that is installed locally on your Mac or PC, feel free to go ahead and try Ubuntu in a VM. So Ubuntu is once again one of the distributions of Linux, one of the very popular ones. And a virtual machine is simply a virtual computer that would live inside of your computer. And so it's going to be an isolated environment as well. You can definitely experiment with it however you want without worrying about breaking anything on your own computer. If you're using Windows, yes, indeed, you can use WSL. However, it's not going to be as isolated as this. So if you're just getting started and you'd like to experiment as much as you can, it's probably a better idea to use something like this at ubuntu.com/appliance/VM. I'm going to leave this up for a few seconds in case you want to take note of it, but it also exists in the slide if you want to click it. And the next link that I wanted to share with you is a tutorial for the command line for beginners. So this tutorial has a bunch of commands that we talked about today, and even more commands, and even more examples for the commands that we talked about today. So if you'd like maybe a more detailed tutorial in written format, you can go ahead and visit ubuntu.com/tutorials/command line for beginners. And that will hopefully give you a good tutorial and some more good information about everything that we talked about today and much more. All right, so this is a link if you would like to take a note of it. And definitely feel free to check out CS50 courses at cs50.edx.org. You can sign up for them and audit them for completely free of charge. So definitely feel free to check that out. You'll find a lot of useful topics that are discussed in these classes. And if you don't mind giving us feedback on this seminar at cs50.ly/feedback, we would greatly appreciate your feedback, and it would help us improve these kinds of seminars in the future. So please go ahead and provide your feedback at this URL, cs50.ly/feedback. All right. Cool. So that was it for a taste of Linux. Thank you so much once again for joining us. If you have any questions, definitely feel free to ask on the Ed discussion forum, and we'll try to answer as many questions as we can. And yeah, have a good rest of your day. Thank you.